Hello class and welcome to science. Today is Thursday, April 23rd. Let's get started. So all week we've been talking about the water cycle. We've been talking about, we did a water cycle interactive notebook. We took some notes on the water cycle, which should have been a review for everyone. You should have talked about the water cycle in 4th and 3rd grade. And also we talked about it earlier in the year when we talked about weather and also weathering, erosion, when we talked about rocks. So now you should feel very, very reviewed. Yesterday we did a lab on density, and we talked a lot about what density meant in addition to why things have a greater density than the other one. One concept I really want to review before we get into today's activity is, again, about density. And I want us to talk specifically about why things in science, if it is deeper, it is more dense. It's the worst E I've ever done in my life. Deeper equals more dense, okay? So density, deeper equals more dense. This was true with the layers of the earth. Remember, the inner core was the densest layer. Inner core, the deepest, densest layer, right? And then when we talk about the layers of the atmosphere, right? The troposphere is where planes fly, the air we breathe, and it is mostly nitrogen, right? So the troposphere is the densest layer of the atmosphere. Whatever is deeper is more dense. When we're talking about the layers of the ocean, the hadopelagic is the abyssal plain, or basically the deepest part of the ocean, and that's also going to be the more dense, right? Whatever is deeper is more dense. Yesterday, when we did our egg lab, when we had regular water, our egg sunk to the bottom. Because the egg is deeper, the egg is more dense than the water, right? The egg is deeper, the egg is more dense. When we put it in salt water, our little eggie floated to the top. The water is deeper than the egg. The water is more dense. So why is that? If you have ever seen a pyramid of people, it kind of helps make this more logical, right? So if we have a pyramid of people, right, and Mrs. Benavides is an awful artiste, so we're not going to judge her terrible drawing skills of all these awful stick figures. These guys are on the bottom, right? Then let's add another layer of people that they're holding up like cheerleaders. Then we're going to add another layer. And then finally, one person, huzzah, yay team on the top, okay? So this is our lovely pyramid of people. Now I want you to think in your head, who do you think is in the most pain right now in this pyramid? Who do you think is holding up the most weight? It's pretty clear if you've ever been in a pyramid, seen a pyramid, or like can even just visualize it in your head. These people on the bottom, they have the most weight pushing down. They have the most people on top of them pushing down because the weight of this guy, these people, and these people are all pushing down on our bottom row. The next worst would be these guys, right? They don't have the weight of these people pushing down on them, but they have the weight of this and this pushing down on it. The person who has the least pressure pushing down on them is this guy on the top, right? Now you might be like, well, I don't want to balance on top of a whole pyramid of people. Whatever. The idea here is that being the person on the top, no matter who's in this pyramid, no matter how this pyramid goes, whether it's a pyramid of puppies or a pyramid of humans or a pyramid of bricks, the ones on the bottom are going to have the most stuff pushing down. The ones on the top are going to have the least stuff pushing down. So why do we relate this to the science that we've been talking about? So when we're talking about the layers of the earth, right, this is our crust. Oh my gosh, my drawing has gotten like worse without practice at school, okay? Pretend this is the layers of the earth. So our inner core is here. We say it's the deepest, densest layer. That's because, like the pyramid, It's this bottom row. It has the crust pushing down on it. It has the mantle pushing down on it. It has the outer core pushing down on it, okay? And it's even pushing down a little bit on itself. So it has all this pressure. That's why it's the most dense or the most close together, okay? If we think about the layers of the atmosphere, this is our troposphere, stratosphere, mesosphere, thermosphere, ionosphere, okay? Which one's the most dense? The troposphere. Why is that? Because not only is it supporting itself, but the stratosphere is pushing down on it, the mesosphere is pushing down on it, the thermosphere is pushing down on it, and the ionosphere is pushing down on it. All of these things are pushing down on the troposphere. That's pushing it together. Therefore, it's the most dense. Remember, dense, more compact, sinks. Whatever is deeper, dense. Sinks, dense. Closer packed together, dense. Okay, let's do a couple more examples of this. If I have the layers of the ocean, right? So I have which we haven't talked about yet, so don't feel worried if this is new. We have the sunlight zone, we have the twilight zone, we have the midnight zone, and we have the abyssal plain. And then we have the trenches. But way down here, this water is being pushed down by this zone, by this zone, by this zone. So all of this water is pushing down on it. It's like the bottom layer of our pyramid, deeper, more dense. If you've ever made a parfait, this is my last example, I promise, and then we'll move on to something else. If I put a layer of marshmallows, then a layer of pretzels, then a layer of ice cream, which one's going to be the most squished? It's going to be my marshmallows down at the bottom. They're going to be much more squished down there because it has all these other layers pushing down on it. Deeper, dense. Density, how squished together something is, deeper, more dense. Faster you get that in the head, a lot of students try to memorize, like, okay, the inner core is the densest layer, this troposphere is the densest layer, the bathypelagic zone is the deepest layer, the hadopelagic zone, get it right, Mrs. Benavides, is the densest layer. You don't have to memorize all that. All you need to know that in science, whatever is deeper is more dense on planet Earth, and you will be good, my friends. So with that, we're going to do a water cycle passport activity. I want you to look at these options: ocean, glaciers, groundwater, soil, clouds, river, animal, or lake. And I want you to think about, remember how we did this for the rock cycle? Which one do you think you'll go to the most? Then I posted on your Wisermate page this link. You can also type it in yourselves, and it will take you there. Just like when we rolled the dice in our classroom for the rock cycle, we obviously can't do that here. So I want you to do this in your Ultimate Science notebook where it says Water Cycle Passport. I want you to fill in the type of data. Hint, we're using numbers. And put a check mark next to each one that you visit. I want you to do this until you have 15 checks on your paper. So for example, if I go to this website and it says I started the ocean, I should put a check next to ocean. If it then sends me to the clouds, I'm going to put a check next to clouds, which I know we've done this before, so all of you should be super familiar. Then I want you to fill in, where did you visit the most? Where did you visit the least? Were there any surprises? I want to kind of front load one of the surprises. Sometimes students are confused that animals are part of the water cycle, which, Bruschetta, you are part of the water cycle. Did you know that? Did you know you're part of the water cycle? No? Is that new news for you? Yeah? So when Bruschetta drinks water, that's when she becomes part of the water cycle. And when she pees it out, that's how she makes it a cycle, right? She's collecting water. She's using it in her body. She sweats some of it out, but most of it comes out as pee. And then that water is evaporated, just like we had in our matter and change story. And the whole cycle starts over again. So think about it. You could be drinking Bruschetta pee. I'm just kidding. Hopefully that was the video you watched yesterday, so that makes some sense. Any surprises? So that's it for today. Very short science video. Feel free to reach out with me to any questions that you might have, and I hope you have a fabulous weekend.